All right, we're going to learn a little bit about solving exponential functions or logarithmic functions. And so you're going to start on page 180 here in your workbook. And what I'm going to do is try to show you ways that you can think about the question and say, how can I get to this answer? Okay, so off of what you're given, though, that's the important part. Okay, so let's start here. These are supposed to be on page 180. This A through F here is supposed to be like a way to get you to explore the idea, to try to figure out exactly what it is that they want you to do. Okay, so I'm going to use these just as kind of like an intro into where we're going to be going. Okay, so one thing you always want to look for is if you can get or if you have the same base. So I'm going to give you some that already have the same base, and then there'll be one like A and B where they don't have the same base, but you can manipulate the question to make it have the same base. Okay, so here's what I mean by that. In part A, 16 is the same as 2 to the 4th power. Okay, so if I turn 16 into 2 to the 4th, x, and then this one is already 2, it's like 2 to the 1st power, then I'm really looking at 2 to the 4x is equal to 2. Now, once my bases are the same, I really only have to take the exponents and set those equal. This one's like a 1. So it would be 4x equals 1. Once my bases match, I can kind of drop the bases. So that's the whole point. And then I'll divide by 4 here, and therefore my answer is 1/4. So let's see if that's true. Is 16 to the 1/4 equal to 2? And yes, that would be the 4th root of 16, which in fact is 2. Okay, so just as a quick reminder, here's another one. I'm looking at a base of 2 and saying, well, I want to write 4 with a base of 2. So then I would take 2 squared, oops, that's supposed to be a squared, and then raise that to the 2x plus 1. So I'm trying to use this other pen that's not going to be, it's not going to make sound every time I use it like the other one does. So this one's a little bit different. But anyway, so I would do, now that my bases are the same, I'm going to set my x equal to, now careful here, I'm having to multiply 2 times 2x plus 1. So that actually is going to look like this. Then I would have to distribute. So I would be solving something that looks like x equals 4x plus 2. Now that is definitely doable. I'm not going to finish it out because I want to go to the next one. Okay, so the next way you might be asked is, what if they're not the same base and they don't have a way to get the same base? Then I'm going to teach you something called where you can natural log or log both sides. It doesn't really matter. So what that would look like when I actually show it to you a little bit later is my base of 2 here in C. I have a base of 2 and a base of 3. There's no way to get to that x and that x plus 1 without using logs and without using log properties, because the only property I have that will work now is the power rule. So if I were to, I prefer the log, but it doesn't really, natural log, excuse me, but it doesn't matter which one you use. So I'm just going to throw an ln in front of the 2 and an ln in front of the 3. Now my power rule applies. So this x that's in front, I'm sorry, the x that's the exponent can now come in front. And over here, this x plus 1 can now come in front of the natural log of 3. So that's just how to start that one. Okay, that's what I'm more concerned with right now. And then the last thing I'm going to be showing you today is just to do a drop switch. So basically change the form. Why? Well, in D here, I have a base of 10 if it's not there. So this would be 10 to the 1/2 equals x. And then all I'd have to do is solve for x. In part E, remember this is a base of E. So it would be E to the 2nd equals x. Perfect. And then the last one would be 3 to the 3/2 equals x. And then I would just need to solve for that. So we're going to be using variations of those 3 major ways. Okay. So let's move on to the next page here, 181. And this is just saying, basically, if your base is going to be the same, then since b to the x is equal to b to the y, you can set x equal to y. So similarly right here, we would have, if the bases were 3, then x equals 5. Hopefully that's self-explanatory for you. All right, and then the next one that I've already kind of explained to you is putting it, basically just writing this into a different form. Okay, so actually we'll skip that one for now. All right, let's get to some of the examples. Now, these are the examples you're going to want to use for your classwork that you're going to do in a little bit, and making sure that you understand how to show your work, because remember, that's always what I'm looking for. All right, so in question 1 here, my thing would be, okay, I see that I have the same base. So once I have the same base, then all I have to do is set the other part equal and then solve. Okay, so I just want to switch over to another thing to write with. It wouldn't be so sloppy. Okay, so again, once my bases are the same, I set my exponents equal to each other. And you know, it's just a basic algebra problem, no big deal. So I'm not going to explain too much here. 12, so x is equal to 4. Okay, and then you just always want to check it. If I were to plug that in up here, I would get 8 plus 4 on the left, which would be 12, and then on the other side, I'd get 20 minus 8, which is also 12. So it'd be 5 to the 12 on both sides. One way to check it. All right, now in number 2, the best thing to do here, I see 4 and I see 8. And at first thought, we might think that we can use a base of 4, but actually we can't, because 4 to the second is not 8. What I want to do instead is think of another base that they could both be. So in this case, 4, I could write as 2 squared and leave the 2x minus 1. I could write 8 as 2 to the third and leave the x plus 2. Okay, so if you notice, I can have my bases the same. Now, careful here, though. This is going to have to be 2 times 2x minus 1, and then 3 times x plus 2. Now, because I do have to distribute, now I would have 4x minus 2 equals 3x plus 6, and you can enjoy your algebra 1 at the moment, because that's all this is. If I go too fast and you don't see how something works, just let me know. Because remember, that's not the algebra 2 part. The algebra 2 part is the very first step. Okay, so here's one where I have not like bases, and I can't make them like bases. There's no way to make a base of 3 or a base of 5. So what I'm going to do instead is that second rule I taught you, which is to natural log both sides. So what that gives me here on the left is x plus 3. Because that drops down to the front according to the power rule. And that is natural log of 3 equals natural log of 5. Now I want to think of natural log of 3 as some number, and it is some number. If I put it in the calculator, I would get a decimal. So the first thing I'm going to think to do is just divide by natural log of 3. And again, you can find that in your calculator. So I would have, I'm just not going to do it yet. I would have x plus 3 equals natural log of 5 over natural log of 3. Then I can subtract 3. So you might see your answer 2 different ways. You could see it written as x equals natural log of 5 over natural log of 3 minus 3. Or you could take that and plug it into your calculator. And actually, why don't you try that? I'm going to do it right now, and I want you to try it too, and let's make sure we're getting the same answer. So I'm going to do natural log of 5 divided by natural log of 3, figure out what that answer is by hitting equals, then minus 3. And that gives me a negative 1.5, let's see, let's say 4. We'll just use 2 decimal places. Okay, so try that. If you have trouble with it, let me know. All right, we're going to skip number 4 for right now, just because I want to show you how to do these also in number 5 and 6. So there's still going to be, these are still going to be natural logging problems, but I need to get this, let me highlight it here for you. I need to get this e to the 1 minus x. And like in number 6, I need to get this e to the x. I need to get that by itself. And the only way to do that is with some algebra work. So what I would do in number 5, my first step would be to divide by 12. That would leave me with e to the 1 minus x equals 500 divided by 12. Oh, which unfortunately doesn't go in nice. Looks like that's 41.7. So that 41.7. It's actually 41.6 repeating. So I'm calling that 41.7. Now I can, and I would want to, natural log both sides. That's one way to look at this. You can natural log. My natural log and my e are actually going to cancel out. We learned that in the last section. So I would be left with 1 minus x equals the natural log of 41.7. And then I would subtract 1 from that. Quick. So I'd be left with negative x equals, I'm going to do this part in my calculator, so natural log of 41.7. If you're opening parentheses, make sure you close them before finishing. And then this would be about 2.73. But notice it's a negative x, so I'm going to just divide by negative 1. And that's what we're looking at there. Okay. Number 6 is going to work very similar. We're going to first get rid of this 14 by adding to the other side. So I'll be left with 3 e to the x equals 25. I divide by 3. Why? Because I want to get the e to the x by itself. And 25 divided by 3 is 8.3 repeating. So just like that. Now, I have not solved for x. I've solved for e to the x. So what I would need to do next is natural log both sides. That would leave me with x equals natural log of 8.33. So I'm just going to do that in the calculator, which would be 2.12-ish. All right, so that's kind of the major idea of those type. Now let's look at ones in the next section where you'd have to actually do drop switch. So we're just going to do these, a few of these down here. All right, so number 7, I don't have a base. There's nothing I could do to cancel anything out. What I'm going to think to do here is drop switch. So if you learned how to do drop switch before, then this should make sense to you, which 3 to the second equals 4x. Now, what I've done is I've completely gotten rid of the log, and now I'm just in exponential form. So 3 to the second is 9. And then I'm going to divide by 4, and bam, look how easy that was. Super easy. Now, in number 8, notice how my natural log is the same on both sides. So when that happens, I actually don't have to do anything. My natural logs, you can kind of look at them as canceling out. It's not that they're dividing out. It's just kind of like that idea we said with the bases were the same. These, with the natural log being the same, we can drop the natural log. So now we have x squared plus 3 equals 4. And then, of course, I need to solve. So I'm going to move this 4 over. And then sometimes you might have to factor, like in this case, with difference of squares. That would leave me with 1 and negative 1. And I'm looking back up at the front, going, okay, well, if I plug in 1 there, I get natural log of 4 on the left. And if I plug in negative 1, I still get natural log of 4. You do want to check for what this says over here, check for extraneous solutions. That's what I just did. Right now, 9 is going to be very similar. You're going to take 8 to the 2/3 equals x squared minus 5. Now, 8 to the 2/3, you already know, you should know how to solve, would be the cube root of 8, and you want to square that. Cube root of 8 is 2, 2 to the 4th is 4. Okay, so now I'm looking at, let's see, subtracting the 4, which would give me x squared minus 9. That would be x minus 3, x plus 3 as the factored part. And then so my answers would be 3 and negative 3. Again, I'm looking up at the top, realizing that they both get squared, so both answers are correct. Now, just because you're going to have one of these on your where you could see one of these. What I'm going to do is get you started with these last two. This video is getting pretty long, so you would be able to finish it out. But I just want to show you that on this side, you can't just drop all the natural logs until you condense. So you'd have to do natural log of x times x plus 2 equals natural log of x plus 6. Now that I have my natural logs that are the same there, I can say x times x plus 2 equals x plus 6. Okay, now of course I would have to distribute. I said I wasn't going to do it, but it's kind of hard for me to not do it. I would subtract x. I'm just going to do it quickly. I would subtract the 6 also over here. So I'd be left with x squared plus x minus 6. And then I would factor. Let me pull this up for a second. I would factor using 3 and 2. 3 and 2, positive, negative. Therefore, x is equal to -3 and +2. Now, I'm already looking at this going, there's an extraneous solution. The extraneous solution is going to be this -3. Because if I plug that in up here for the natural log of x, I would get natural log of -3. And if you refer back to the graph of these exponential functions, there's no such thing as a negative. There's no way for me to take e to some power to get a -3. So that is impossible. So I would call that an extraneous solution. My only solution is 2. Okay. And then number 11 is going to work very similar, where I want to condense the left-hand side first. Ooh, so that'll be x plus 5 over x minus 2. That's 3. Then I would do 2 to the third equals x plus 5 over x minus 2, which is 8. Okay, and then I like to think of this as cross multiplication. So I would do 8 times x minus 2 equals x plus 5, and then I'll just finish that out real quick. I know I'm doing this fast, so feel free to stop the video, write something down if you need to. Let's see, that's plus 16, 21. And feel free to stop the video, back it up, rewind it, watch without writing if you need to. I'm checking this for extraneous. If I plug 3 into that function, I don't see anything that's undefined. So it seems like that one would be okay. So what I did is I gave you a lot of quick examples, and that's because there was a lot of experience needed for these types of questions. So what I want you to do is to try your practice, use these to go back to. I'm not going to give you anything that's not like what you see here. Okay, so please really try to match it up and understand what we did and do well on those questions, I guess, that you're trying to solve, all the problems that I'm giving you. Please ask, though, if you have any questions, and good luck.